All right, welcome back. So this morning, I think we're going to have a very interesting and informative panel. The topic is where will urban mobility be in 20 years? We have an outstanding panel. Their full bios are on page 47, so if you want to read the detailed bios, they're there. We have two moderators. We have Sandy Lozito from NASA and Munish Khurana from EUROCONTROL. And so with that, I will hand it over to Munish.
Thank you, Eric. That's the best and the shortest introduction I've had. I love it that way. I'll try and follow your example if I can. Hello to everyone. Thought-provoking presentations this morning. I hope you enjoyed it. And thanks for the earlier speakers to set the scene for urban air mobility. Before I introduce our panel, I just want to say a couple of words about what urban air mobility means. Actually, it means different things to different people. When I ask my mum, for her it's fantasy land. She doesn't get it at all. And I go and talk to my 16-year-old son, and he says, "Yeah, bring it on, mate. You know, I want it now." You know, it's different things to different people. So I think hopefully today we're going to have a panel where we're going to go through these issues, look at opportunities and challenges. So with that, I'd like to introduce my first panelist. That's Dr. Joerg Mueller from Airbus. Dr. Mueller is the head of programs and strategy within the Urban Air Mobility Division of Airbus. Joerg, would you like to highlight what you would bring to the urban air mobility, please?
Yeah, thanks very much. Thanks very much, Munish. I'm very glad to be here actually and talk about the vision of urban air mobility to this community, to the ATM community. Because just to illustrate that, I had a little discussion with a pilot in London that operates a helicopter, police helicopter, and he was telling me, well, you know, the London airspace is very crowded. We have 5 airports, all the incoming, outgoing traffic. So if we get 5 helicopters in the air at the same time, then it's getting really, really busy. And this is obviously not our vision of urban air mobility. To make this happen, we need more than 5 flying devices in the airspace. And to make that happen, the vision of the ATM community needs to align or needs to contribute to the vision of urban air mobility. So very excited to be here and discuss what this world could look like. Now, knowing that urban air mobility, as you said, is a terminology that is used for all kinds of different uses. When we created that at Airbus, we were looking in 2014 actually, we were looking at societal needs on one side and on technological progress on the other side, right? And there is a clear trend, mega trend to urbanization, and so the need for mobility in cities, and everybody who lives in a bigger city or even smaller cities experience it probably every day, what urban congestion means. And it's a real harm to society. It has a macroeconomic impact that is pretty negative on society. So there's a clear societal need, and there's technologies that emerge that become ready for providing new solutions, aerial solutions to that. And it's obviously all around electrification, about automatization, autonomous flight, connectivity, new business models, selling service to passengers, and bringing all that together created this vision of urban air mobility. Then it becomes actually an interesting vision for a company, because there's something that we can bring to society. There's a need that we can solve with a product and service that we can offer, and it becomes something that can create value for all of us.
Thank you, Joerg. Thanks very much. My second panelist is Mr. François Sillion. François is the director of Uber's Advanced Technology Center in Paris. François, a lot of people know about Uber, what's going on and stuff. Perhaps you could enlighten us on what you would bring to the whole domain, please.
Okay, so Uber sees itself now as a general transportation company, and the goal really is to be able to provide and bring together all of the mobility options that will exist and provide the passenger or the consumer a seamless experience traveling from one point to another. And in general, this will involve multiple segments, because if you start traveling a significant distance, we think in particular air mobility will be a key component of that. And our vision is, of course, Uber is a technology and software company primarily, but using all of this technology to build a platform that integrates all of this together. That's really our vision. And so in terms of urban air mobility, we're looking at passengers, so basically flying taxis, or but also the delivery, for instance, of food or other things. Just a quick word to say that basically Elevate is the part of Uber that deals with all of this aerial transportation. And the center I'm building in Paris is focusing on the technologies and research that deal with basically the software part of all of this. So artificial intelligence, optimization, software safety, and of course autonomous piloting.
Thank you, François. My third panelist is Mr. Markus Klopf, who's the Director of Strategic Marketing at Frequentis. Markus, would you like to enlighten us where Frequentis stands on this, please?
Yes, of course. Hello and good morning from my side. I'm pleased to have you all here in Vienna, which is actually my hometown. So I hope you're enjoying it over here. Frequentis is also based here in Vienna, in Austria. What we are doing, we are mainly a communications and information company that provides mission solutions for mission-critical control rooms in air traffic management, in defense, but also in public safety, public transport. And that's where it all comes together, really. When we look at UAM, urban air mobility, we take it from the side of UAV traffic management, and where we see it's coming together is really this kind of thing which is about multimodal transport. There is the connectivity and the connection of air, but also the connection ground, and the different choices that you can make as an individual to go from one place to another. Just a little story from my side. 2 weeks ago, I was in Washington, D.C. I went there on a nice flight, but I have to say the flight was everything. The flight was great. The flight was punctual in time, no delays. But everybody who knows how is it when you're driving in Washington, D.C. on 3 or 4 o'clock in the afternoon, and you have to take the Beltway, there is a case for urban air mobility, because the traffic jam there is plannable, it's always there, and it takes 3 hours for a ride that normally takes 1 hour. So I would love to have the choice at Dallas Airport to jump into an air taxi and go to our office there. So this is definitely, that will be one of the visions. I was always also talking to my sons, preparing for these panels, and they're a bit younger, and I asked him a question: do you think you want to have a car, or do you think you own a car in the future? He said, well, maybe not. Maybe he wants to have an urban air taxi in the future. That's what he really would love to have. Thank you.
I'll hand over to Sandy.
Good morning, everyone. Just a few words of introduction of myself and NASA. We've heard from Akbar, and we've heard from some other folks about what NASA is doing. My name is Sandy Lozito. I am fortunate enough to run a division on air traffic management at Ames, the Aviation Systems Division, where we do a lot of the work, not all, but a lot of the work on UTM and urban air mobility, much of it funded by Akbar and the program that he already discussed. So we're very pleased to be involved in this, and I'm very pleased to be here. And I also want to extend my thanks to all of our panelists. I will now introduce the US panelists, and I will start with, I like to use his full name when I can, because I think I can still pronounce it, Parimal Kopardekar, PK, as we all know. And PK, would you like to say a few words about what your viewpoints on UAM is?
Yeah, so thank you, Sandy. At NASA, we have been working on advanced air mobility. Urban air mobility happens to be part of advanced air mobilities. The idea is to start using the third dimension in the airspace to increase the mobility and access for cargo, goods and services, as well as people into remote areas as well as into the urban areas. So we did a couple of market studies, and we discovered really good opportunities and interest from the market towards advanced air mobility, including the urban air mobility aspects, and that's how we are focused on. Then we looked into the challenges associated with the enabling such urban air mobility systems, which one of them happens to be air traffic management, other ones are noise and manufacturing and such. But so we are going systematic, step by step. First, we understood the market potential, the need. Second, we are looking at the barriers. Then third, we are figuring out strategy to address the barriers. We also developed something called Urban Air Mobility Maturity Levels, UML. We are really good at creating new acronyms. So that's another one that we created, UML. The idea is to show that in order to make urban air mobility a reality, you need to have airspace operations, aircraft, as well as infrastructure and community, all pieces evolve together simultaneously so that you can go from low density to medium density and medium complexity to very high density, high complexity type operations. So I would encourage you all to take a look at the UML definitions and the market studies that we have published.
Thank you, PK. And I am also pleased to introduce our second U.S. participant, a man who also needs no further introduction to this crowd, John Hansman from MIT.
Yeah, so thanks. It's interesting to think about urban air mobility. I've been working on it since before we had the term urban air mobility, right? And it was actually motivated a lot by people that were interested in the electrification of the vehicles and whatever. We got involved in it looking at operational constraints. So it turns out it's not the vehicle. We can fly the mission today with vehicles that we have. We can use helicopters. When you look at the operational constraints, we did, I'll just give you the anecdote of the first case study. So we did a case study in Los Angeles. Los Angeles was supposed to be the easy place to do this. Weather was good. There was clearly a demand. And by the way, there's definitely a demand and there's investment. There's over $3 billion been invested in this area. So there's definitely something that's going to happen. I don't think it's going to be what Uber thinks they're doing, but that's all right. Okay, so if you look at Los Angeles, part of the reason why we went there, and Mark Moore, who everybody knows, was a big advocate. It was supposed to be easy because the weather was good, and by the way, there was a zoning requirement that every building greater than 8 stories had to have a heliport on the top of the building. So this should be an easy place to operate. So we did basically a market analysis. We looked at where people would want to fly. We came up with candidate missions. Interesting things. All of the 8-story buildings in Los Angeles are within 2 miles of each other. So if you look at what became the constraints, first was takeoff and landing areas. It's going to be in the places where you have the market, it's going to be very hard to locate takeoff and landing zones. Even if you put them on top of buildings, most of the buildings actually aren't structurally sound enough to take that. So we have to think about the takeoff and landing area and how you locate those. That relates to another constraint, which is the community acceptance. The vehicles are going to be you're going to have to blow air to move these vehicles, so you're going to have some sort of noise. And there's also other community concerns. So one of the things that we've learned from a lot of work on other aviation noise is that that's going to be a real issue. So that couples to where you're going to be allowed to have the takeoff and landing zones and the community acceptance. So I think we have to think about that. In all likelihood, you're going to have a limited number of zones. And what that means is the vehicles are actually going to be bigger than the 2- and 4-person vehicles, because a lot of the missions are trying to get around surface congestion, so there'll be commuting missions. So we need to be thinking not only about taxis, but we need to be thinking about urban air mobility buses and things like that. The second big constraint was air traffic control. In the 12 reference missions we had in Los Angeles, 11 of them had a takeoff or landing site within a class B, C, or D airspace. So that means that you're going to have air traffic control interaction if we operate the way we do today. We can do that at a low scale, but you can't do it at a high scale. Highest market in the world right now for these services is Sao Paulo. Up until a few weeks ago, the maximum number of helicopters you could have in the air over Sao Paulo at any one time was 6. Okay, so we don't have scalability to the black clouds of these vehicles flying around. So we have to think about that. When we do think about that, urban air mobility will be a lower priority than commercial transport aviation. So we will have to find a way to do this that will be interoperable with conventional transportation. I think the technology is such that we have opportunities, but we have to take advantage of the PBN capabilities that we are using today but are really not taking airspace credit for. So we're going to have to find a way to do this that interoperates with not only the conventional transport, but the other users for the low altitude airspace, which will be the UAVs, the police and fire, and things like that. So I think that there are real opportunities for particularly this community, because I think we're really the enabling capability for UAM, which is going to be the air traffic control, low altitude operations.
Thank you, John. And our final, last but certainly not least, our esteemed colleague Natesh Manikoth with FAA.
Thank you, Sandy. It's wonderful to be on a distinguished panel like this, so thank you for the opportunity to have this conversation. My main goal is going to be to try not to make news. But Joerg is recording us. So in preparing for this panel, I tried to make sure that I talk to some of our FAA colleagues who are more closely associated with the UAM efforts. And so a few things, kind of distilling things which we have kind of stated in public before. Great business opportunity. We want to support the emerging market and industry. Lots of challenges. Not all of them are operational or technological challenges, which most of this community is interested in. As John already pointed out, regulatory challenges, infrastructural ones, societal acceptance, those are equally valid and critical things which we have to kind of think through and overcome. FAA's position on this is we are open for business. So if you have a Part 135 operation which you want to certify, please go meet the right folks at FAA. They are ready to work on those. There are current cert efforts already in play. A couple other things. So on the regulatory side, one of the pieces, I believe, the small US efforts in the past, the Partnership for Safety, the IPP projects which are going on, have kind of highlighted is that it is better to look at the intent of the regulation sometimes. The classic example several of my colleagues cite is the requirement for a pilot manual in the aircraft. It doesn't make a ton of sense when the pilot is on the ground in the US. So the intent obviously is that the pilot should have the manual close by kind of thing. So the intent of the regulation is probably the place where we need to go, so the performance-based standards. So that the agency has kind of shifted its thinking in that direction clearly. The other good news for folks who are interested in the Uber Elevates and the Airbus of the world, our acting administrator, Dan Elwell, I think as early as last November, has kind of indicated the fact that we are making sure that we are structurally organized to facilitate the conversation that the industry needs within FAA, so that there is a coordinating function and to adapt and react quickly to what the industry needs FAA to do. I believe it was in Akbar's presentation this morning, you saw that the small US is, the UTM concept was introduced prior to 2015, but I remember in 2013, 2014, most of the US conversations were about integrated operations in the NAS, and all of a sudden things shifted so dramatically. And so I think we should have a certain humility that we don't know what exactly will happen in the next 10, 20 years. And also we should have internally the ability within FAA to react to what the industry needs and be able to change what the industry asks of us. So looking forward to the conversation.
Go ahead.
Thank you. So just a little bit about the logistics, but also note that in addition to getting a mix of European, US, and different academia, industry, government, we also have clearly some different viewpoints, and this is what we were after. We discussed it. We wanted to have a nice discussion with different viewpoints, so we're really encouraged by that, and we were trying to assemble that. Now for the logistics. So Munish and I, together with some other folks, prepared some questions for our panel, and we've also have sort of the direction of where those questions are going to go. We may not get through all of them. We will reserve 15 minutes at the end for questions and comments, so bear with us. We'll be able to do that. And just one quick note that I want to point out, because I know there will be discussions later on. As it turns out, PK has a constraint, so if you need to talk to PK after, you will need to email him because he'll be dashing off for a flight. So we just wanted to let you know, because there may be discussions over lunch, but not with PK, and at least not at this time. All right, so I have the first question, and the first question will go to PK. It will also go to François after PK, but PK, for you, what are the most significant drivers to UAM?
Yeah, the significant drivers to UAM, of course, is the traffic congestion and giving ability for people to save time and get good services and the transportation at the fastest possible manner without having to wait for anything. Society is getting more and more excited about getting things on time earlier and sooner with shorter period of waiting time for anything. So that's one driver. The other driver is basically push from investment community towards new technology. So we see three classes of folks who are investing into urban air mobility. So you have the Airbus and Boeing, Bell, and so the classic aero companies. We have private equity companies as well as very ultra-rich people who are funding it, like Larry Page, Zero, and such. And then we have venture capitalists who are funding these companies. For those who are getting funded by venture capitalists, it's somewhat easier to get the first round of funding, 10, 15 million, maybe second round of funding, a little bit easier, but the third, because the cost of certification is going to be 500 million to billion as postulated by many folks. So if we want to contribute to this urban air mobility challenge, then we really need to focus on figuring out what data, what analysis, what kind of methods and techniques we need to use to give some assurance that this is going to be a viable idea. There's a market potential, but it needs to be matched with approach to scalability and viability. And that's what I think our community here, ATM community, as one of the big barriers for this is really the air traffic management, as everybody's talking here. And I think the interoperable, digital, intent sharing, scale-free air traffic management and airspace operations is one of the keys to that success. So that if we can conduct research and that will formulate requirements to get to that high scale without compromising safety, that's when we will see the investment community continue to enrich this market and the true potential will be unlocked.
And François, for you, what are the drivers for UAM from your perspective?
Well, first of all, I could, I guess, repeat most of what PK said, but maybe one word about stating that the main driver is gaining time and removing congestion. I think we have to be clear about this, that it's not going to be, it's probably not going to be mass transportation such as could be provided by rail systems or things like that. Even if we manage to have airborne buses, which is another challenge in terms of technologies. But so one question still, I'll start by that, is it should be large scale. So maybe not mass transportation, but it should be large scale to have an impact on congestion. And also, I think, for us, it's important that it doesn't limit itself to something for the ultra-rich people who can maybe already afford a helicopter ride. But there are many other issues. So it's not just technology. For instance, public acceptance, I think you mentioned it, will be crucial. And so this will have a lot of impacts in terms of what type of service can be developed. And in fact, I would go as far as saying we don't know exactly today what will be. In fact, rather than speaking about public acceptance, I'd like to talk about public desire. Does society, do people, do communities want this? And so, of course, most people would like to have a fast transportation means. They would like to avoid congestions, but not at all costs. So that's one thing. And one of the very significant things, it's similar to what you said about the different parts of investors and different parts of the industry coming together, but really it's all the more obvious for me. I'm coming from a computer science background and IT technology background, and we have to make sure that we manage to work together. For instance, this crowd and people like us who are working on establishing platforms and systems that can connect and interact with each other in the sense of computer and technology systems. there was a in this morning's presentation about next gen. There was something I really appreciated. I don't remember the acronym, but about going all the way from the pushback of the plane to climbing to the altitude and finding a spot. And we would just add to that, the first mile and last mile experience, as you said, when you arrive in DC and you need to make your way. And so all of this requires that different people who have completely different knowledge, language, and skills have to find a way to work together. So that's one really, I think, of the main challenges. And I found there was the Uber Elevate Summit 2 weeks ago in DC, and I found it really interesting to see that various industry players, the FAA, everyone was sitting in a single panel, just like is happening today. And so really, I think the people are realizing now that we need to do this work together. It's not entirely clear what will come out of this, and so that's why we have a lot of work to do. That's why it's interesting for me to have a research and technology lab. But I'm pleased to see that at least we're realizing that we have to work all together.
Thank you. Interesting thoughts have come through. There's one question in my mind, and I'd like to phrase that in my next question. In my next leading question to the panelists is, amongst other things such as being efficient, if efficiency is something that urban air mobility will provide, what about the cost of fares? Do they need to be reasonable, and what is a reasonable cost for anyone going from one place to another? I know recently a German company called Sillion, they did an estimation, and they said that they're estimating that a figure of around $55 would be the cost to take a ride from JFK to Manhattan. I don't know how accurate that is, but that's an area where it would make anyone think if that's a reasonable cost or not. With that in mind, my question to the panelists, and I'd like to start first with yourselves, François, based on what you just said, and then move to Joerg. What do you see as the outlook for the whole UAM, bearing in mind the cost, the efficiency, and the challenges over the next 10, 20 years?
First of all, I'm glad you're only asking for a 20-year horizon. Next week in Paris, I'm being asked for 30 years horizon. And so, being a researcher, it's actually difficult for me to commit to things that I'm not sure of. Of course, now I work for Uber, so I have to answer your question. So. Really, the vision we have, as you know, probably, we've announced that we want to start a first commercial service in just a handful of 3 cities in 2023. So this will, of course, operate in special conditions, waivers of different kinds to make sure that we can fit in the available regulations and everything. So first, I'll answer for 10 years. The idea is that, hopefully, in 10 years, there will be an adapted regulation that allows us to, at least in a number of markets, grow to a significant size that allows us to benefit from the network effect. So as you start, and I don't minimize all of the difficulties that you mentioned, but if you start having a number of stations or vertiports, skyports, then you can really benefit from the network effect of connecting all of these together rather than having a fixed graph layout on the ground. And so that's something that can also help to optimize the operations and therefore bring the cost down. In bringing the cost down, of course, the efficient operation of the platform, teaming up passengers, filling up the aircraft, making sure that you can always provide a solution even when there are difficulties, storms somewhere or difficult weather conditions. So that will be an important factor to drive the cost down.
Thank you. Joerg, from Airbus' point of view, where do you see the next 10 to 20 years?
Yeah, perhaps to answer your first question on the fares very briefly, what people are willing to pay. In general, we had observed that in Western countries where taxis are relatively expensive and people value time, If they can save half of the travel time, they would be almost willing to pay twice what they would pay for a taxi. That's a rough roll, right? A bit more than for a taxi that they would pay for a taxi today. And that's about our hypotheses. And when you use kind of relatively conservative hypotheses of how the traffic will evolve, then we see a significant market in the, let's say, 15-year horizon roughly, and that is so significant that we think that it's about a 50 billion euro market accumulated in the first 15 years for basically the transport fares that people pay globally in the world. If we develop to 50, then 100 cities roughly in the world. That's about the order of magnitude. So this is a very significant number. But when I asked my Airbus corporate crystal ball, is it 50 billion or is it a bit more or less? Then it was pretty foggy in there. And actually, it's really difficult to say. And that's why we are doing at Airbus as well, as many others as well, we're having an exploratory strategy. We are exploring what it takes. We are experimenting whether it works. We have a helicopter service in Sao Paulo, for example, in Mexico City. We are doing all these tech demonstrators to see what technology can bring us to a silent, economic, and competitive vehicle. We are working on air traffic management, on ground infrastructure to get all the building blocks together. And we think there's the potential that this makes a big step change for our industry. How big it really is really difficult to say.
Thank you, Joerg. Markus, what would Frequentis' view and vision for the next 10 to 20 years be?
Well, I would like to go back to some of the comments that I've made here to ATM as a limiting factor of all this, because I share this view, and I think it will only work if ATM is involved and included in the whole concept. And I would picture this as two things. You have this marathon runner of air traffic management, or even it's an ultra runner. So it runs for more than 70 years. The concepts being defined in ICAO, these are concepts that are there and have grown and have improved. And at the end, it's the most safe operation in the world that we see now that have been defined by ICAO. And now you have this sprinter of drone traffic, US operations. They are here to come. They want to run a 400-meter dash, and this is the things you have to bring those things together. And there is progress in this. There is things going forward. So I would say a couple of years ago you had these newcomers coming in there with a concept. Okay, I want to fly. I want to put my drones there, and I want to have them fly. But I didn't care too much about integration of ATM and safety. That has changed. That has definitely changed. There are things going on at NASA with UTM, but I would also like to mention NUTS in the UK, for instance. They had this Operation Zenith last year where they were flying drones at an airport with live traffic, actually, not closed off. Also New Zealand and lots of other countries are taking the first steps now to integrate drones. So this would be the step number 2 in making this possible. The step number 3 is really the true convergence of ATM and UTM. And one of the examples I would like to bring here is from EUROCONTROL and is CESAR, the Gulf of Finland U-Space large-scale demonstration that was just kicked off 2 weeks ago, where they were flying, or 1 week ago, where they were flying for the first time in the area of Tallinn in Estonia and also Helsinki. And they had drones flying there with different missions, with maritime missions, police interventions, and different kind of things. And there is lots of learning, so it's still too fresh, so I can't bring up any learnings here. It's really brand new, but they are progressing there. What's not happening there is the scale perspective. I think this is the next phase. When we have all these operational concepts defined with UTM and ATM integration, and that's also I think urban air mobility is definitely driving this, because urban air mobility, right from the start, appreciates safety as being paramount, because it's about people, it's about persons who want to be transported. So this is definitely driving this. Once this system has scaled, I don't know what's going to happen with ATM. I'm sure ATM as such will also evolve, but that's going to be something for the future.
Thank you. So we've heard from several people, including Akbar's presentation, several of our panelists, that certainly one of the big challenges is scalability, and it's also a requirement for scalability. So with that in mind, I have a question that we'll start with John and also ask Natesh. The question is, what is the biggest threat, or what are the biggest threats to urban air mobility?
So I think we can do it today at a limited scale. So the real question is scalability. And it gets exponentially harder with scale. So the costs are going to go. So typically when you increase scale, things are supposed to get cheaper. Air traffic is going to get more expensive as you go to scale. So, and there will be threshold barriers. One of the questions I have on the cost thing is, who's going to pay for, and how much is it going to cost to do air traffic control? Is this going to be a general service, or is this something that you have to pay for? If we have to pay the real costs, it's dead. So there is a real question of how we do the scale. So I think that's an issue. I think the other issue is the safety and public acceptance question. So there's the noise question. So will you be able to cite vertiports? Again, from Boston, our example, the General Electric moved their headquarters to Boston. One of the agreements was they would get a heliport in the downtown Boston area, which would be the perfect location for urban air mobility. And after 2 years working at it, they were willing to accept that they'll have to take a ride to the airport, that they weren't going to get it. So I think it's not so easy. And these are not just, it varies by country, but often these are local regulations that make it difficult. So there's a real challenge there. The other one is safety. So a lot of the vehicles that you see, conceptual vehicles, are probably not certifiable within the existing regulations. So many of the eVTOL concepts have unsurvivable failure modes below 400 feet. And so we don't really know yet how to do that. So there are interesting technical challenges. I think the vehicles will actually modify, and people will, there is a path through, but the conventional ways of doing it in terms of redundancy just don't close as a technical vehicle design problem. So I think it's the safety, the acceptance, and then how are we going to do air traffic control at scale?
Thank you, John. And Natesh, same question for you. What are the biggest threats to scalability?
Scalability. I'm glad that John handled the vehicle kind of thing, so I don't have to be the FAA guy talking about the vehicle threats. So I think John also alluded to the significant operational integration which is required. The current modes of procedurally kind of tackling some of these things obviously won't work. So dynamic integration of these things from an airspace for this community in particular, we have kind of worked at the fringes of those issues, but it would have to be at a completely different order of magnitude for that to be effective. So I think that is a huge kind of thing which we could work on collectively. I would also kind of cite, not as a threat, but let's not overlook, so let's take the small UAS market. The safety issues are probably easier, but security was overlooked. So the societal impacts for some of PBN, everything works, but then the societal acceptance issues. So I think it would behoove this community to kind of look at those issues early on and aggressively address them, because it is trust in the systems that the society has to have, and those are not necessarily technological issues that the community is used to addressing, but those might be the bigger issues once you get past certification challenges and so forth. So that's what I would submit, that we have to collectively think about, not just, hey, can I create a cool algorithm, but will people understand that the algorithm is fail-safe and it's working, and so the society's trust in these systems.
Thank you, Natesh. Both of you guys have set the scene very nicely for my next question. I'd like to go back to what Paul Bossman spoke about earlier in the plenary, about the work that certainly in Europe we are doing to try and integrate the small USs and the air taxis in the ATM. And I can tell you at EUROCONTROL, we've got a team that's currently working in Riga trying to do an assessment, an airspace and a ground assessment using an EASA authorized SORA technology, SORA methodology, to see what comes out of it. And I agree with John. I think our findings are sort of similar to what you guys have just highlighted. It's a minefield. There's a lot to do. With that in mind, what I'd like to learn from the panel is, bearing in mind the impact the UAM operations will have on the overall aviation operations, other than the ones that you've highlighted, please highlight more if you can, but particularly also then focus on where Europe and United States can jointly collaborate to see how we can help each other out. Because at the end of the day, unless we get this industry up to a certain stage, it won't go anywhere as such. I'd like to start this question first with PK, representing the NASA view, and then to Natesh, representing the FAA, and then to a global company like Airbus, who has operations on either side of the pond.
Yeah, so there are a number of areas just related to air traffic management and airspace operations where harmonization is going to be very important. Give an example. A bird strike happens. So what are we supposed to do when there is a bird strike? The decision is to continue forward the flight or land at the nearest possible vertipad. Now you need to have a digitally connected environment where you need to know where the nearest vertipad is that pad available or someone else is using it, what the weather conditions are on that pad and such, so that you can make those real-time decisions to get to the safe landing spot. You could also have your trajectory planning such that the vertipads, alternate pads are along the way identified and pre-planned. So all these pieces have implications on how much battery you need to carry, how much energy density and energy you need to carry, and what your reserve fuel requirement is. For those who are general aviation pilots are aware that there is a reserve fuel requirement usually, and that's going to translate in a different way because these flights alone are only 20 minutes. So the conventional reserve fuel requirement doesn't apply in this situation. So you had to go through this exercise as to figuring out how actually you're going to scale these operations, and in case of disruptions like bird strike or large-scale GPS outage or large-scale weather thunderstorms, so things like that, which will require a very tight coordination among many, many actors and multiple entities to get everybody to a safe spot. So that's an area where I think there's a lot of interest and a lot to be yet solved. And there's a good bit of harmonization is needed because these operational characterization would have to be standardized.
Thank you, PK. Natesh, your view on this and how US and Europe can collaborate to jointly solve some of these challenges, please.
Do more of these.
Thank
right?
you.
There's a great example of ongoing collaboration between FAA and EUROCONTROL spanning decades now. In pushing the boundaries of what is possible. I believe aviation in general has a global perspective. It's always been on the question of safety. We have never competed. It's always been a cooperative effort to improve safety within this industry. So I think that has to and will continue. The structures are in place to make those things work. And to the earlier discussion about Uber Elevate, I was not there, but I can imagine most of the parties who are instrumental to these conversations are global entities, are working in multiple countries already, working with regulators across the boundaries as they should. So natural collaboration, I think, is happening in the space. In terms of accelerating or more active collaboration, I think this community has started. So we have had a UAS track, so sharing, understanding, and emerging problems, understanding of emerging problems, I think is something which this community can continue to help with.
Thank you, Natesh. Joerg, Airbus being a global organization.
Yeah, I just can underline what just was said, right? So we need obviously global standards so that we develop a product or a service that it can be utilized as broadly as possible to make the business case close. Very simple. And okay, services are usually always a bit more adapted to local markets and to local market needs. Products that are in the aerospace area, very heavy investments to develop and certify such a vehicle, need to be amortized broadly. So obviously we need a broad and ideally as global as possible dialogue around that, so that we have the right frameworks for doing that. The second point I wanted to make in terms of interacting with air traffic close to airports. So a very clear discussion in this case was the Aviation Authority of Singapore, or rather the Airport Authority of Singapore. They were saying, okay, this is a great idea to provide urban air mobility, but make damn sure that you do not disrupt my airport operations. All right? So if there's one large commercial airline in such a busy airport, just delayed by a couple of seconds or minutes, that has a huge impact, an impact that a little air taxi with 2, 3, 4 passengers cannot compensate in terms of benefit. So they were, this is just one example, there's other examples where they were very, very keen in having solutions that make sure that this additional traffic that we are generating in the airspace around it doesn't have an adverse effect on airport operations. For our business case, it's super crucial actually to be close to airports, because we think that passengers from airlines, especially the premium ones, are one of the first adopters of such a service. It's the typical route. You have spent thousands, often thousands of euros to fly an intercontinental flight. You arrive, and then you have a 3-hour taxi ride in front of you before you get to your hotel or to your meeting, right? So you're usually able to and willing to spend a bit more to get there efficiently. So for our business case, it's obviously crucial that all this works perfectly well together, and we do not create friction in the system on that end.
Thank you.
And we will stay with you for the next question, and then we'll also ask PK and I forget who else gets this question. Oh, François. The question is, do you see a potential early win that could come up relatively soon, that could help convince and sell and offer promise in the area of urban air mobility?
So if I have the pleasure to answer this difficult question first, then I will try at least, right? So from our experience, obviously we are doing an air taxi service today with helicopters. But this is a challenging exercise, right? It's challenging in terms of noise and acceptance in the city. It's challenging in terms of cost and business case and so on. Yes, it helps us to build a strategic position and to develop the ecosystem. We are experimenting with parcel drones. We use that especially in this is a Singapore example again, where we use parcel drones to integrate them into the airspace and test what it takes to work with the authority, Civil Aviation Authority of Singapore in that case, to develop the regulatory frameworks and the technology at the same time to be able to integrate. So, okay, this is also more like a strategic investment. In terms of a quick win, what you would say, okay, we are already harvesting it today. We've heard a bit earlier today that it's difficult to make money out of the drone business up to today. You know, we're having a service that is doing drone imagery, and that works well for insurance purposes, for example, that needs some information about real estate in this case, or that works well if you need some reconnaissance after a catastrophe, natural catastrophe or something like that. Then you can provide very quickly data thanks to this new means, thanks to drones. But all this needs to develop, as we learned this morning. It needs to develop to become to this big numbers of drones operating, this big amounts of services provided with them that we imagine. Thank you. François, question for you. Do you see an early win, for example, if not for nothing else, a way that we can start collecting data for some of this, which I know Uber Elevate was very interested in.
I certainly would say an early win rather than a quick win, so I don't commit to any time frame. So basically, I agree with. I have a similar view to what Joerg said. What I can mention is on the drone side, Uber is actually working in one of the integration pilot programs of the FAA. We're part of the program in San Diego, where we will be experimenting and developing a service to deliver food, basically. And I think that's certainly something that can be done fairly early, because it's actually easier probably than for moving people to really define to have a well-defined and perhaps constrained in many ways application scenario with many operational constraints, and then we can limit the service to particular areas, for instance, more easily than for transporting people where the people know where they want to go. The food delivery business is more distributed spatially. Now, in terms of moving people, we also announced that we will be starting a helicopter service in New York City, for instance, going from Manhattan to JFK this summer in July. And this is an example where it's not necessarily an early win globally in terms of the scale of operations, but it's very interesting in terms of studying in a sort of a sweet spot of transportation where it's the right distance. It's an area where there are already existing helicopter routes that can be used. We can use the existing certifications, vehicles, and things like that, and we can use that to really test and refine the model of this multimodal transportation scenario. So I think that's really important, and then that will be used, of course, when we have the next generation of vehicles and vertiports and everything.
Thank you, François. And finally, for PK, a question about early win.
Yeah, so in terms of early win, we want to be quick, but we don't want to rush, obviously. And I agree with François, there's helicopter type operations which will scale and not overly burdensome to air traffic control system, current air traffic control. So it could be cooperative, more digital, more intent sharing, using third-party services, use the paradigms of managed by exceptions as we are studying through UTM would be a model to apply to these operations in the early stages to see if we can start to scale these operations. Till noise becomes a problem, then we need the electric VTOLs. But we can start to test these constructs through helicopter operations and adjust the ATM kind of services. So that's on one side of the helicopter operations. On the second side, we could also start to see some eVTOL type experimental operations in perhaps some remote areas like Grand Canyon. Right now, the deliveries, this is just an example, but deliveries at the bottom of the Grand Canyon are done by mules. So you could consider using something else that's a little bit faster, even though they both will be environmentally friendly. So the idea is to try it out at the low risk areas. Another example is between Hawaii Islands, where the distances are 40 to 70 miles. I used to say in Alaska, but then say who wants to work on that project? And where if Hawaii, like everybody wants to work on. But so that's an example where there are opportunities where we can actually test out before going to the most congested, most sophisticated airspace and operations such as New York and such. We could try it out at the places where this could gain some value as well as in a low risk area.
And Markus.
Well, solutions that we could offer here in products, of course, we are an industry, we're a product supplier, and there are products that we can offer to the air traffic service management providers today that are helping them to resolve the issue of drones in the airspace. Because when I was talking to a lot of air navigation service providers recently, and for them, drones and urban air mobility is a threat and a chance at the same time. A threat because of safety, but also because of the question of, okay, who is going to pay for the service that they have to provide for them? There's nothing set up. They have usually in no country they have a mandate to do so, so it's still in flux who is actually doing this service. Some countries, some nations said, okay, you are the NSP, you are the prime service provider also for UTM. For some, they are still fighting to get the chance, so this is definitely a threat. The products that are there today and that's also what is being tested right now and explored right now in the CESAR trials, for instance. One of the big concepts there is the flight information management system. So this integral part of data platform that is there to share all the information among all the stakeholders. And I mean, when I speak to stakeholders, I say it's the drone pilots, it's the air traffic service providers, but it's also police, firefighters, and everybody else who is actually in the need to know what's going on in the operations. There has been a lot of work on swim on both sides of the ocean, and the Swim Global Demo 3 years ago now was a perfect example on also collaboration of Europe and the US on getting swim into place. And now we see that system-wide information when it's swim is a key aspect of sharing that information and making the things possible here.
Thank you, Markus. I'd like to move now to address the more softer aspects of the urban air mobility as such. I think we understand that most people don't understand urban air mobility. At least man walking on the road. I think people in this room probably understand better, but a man walking or a woman walking on the road, they don't. So there's a role to be played to educate people on what the benefits are and the risks are related to the whole urban air mobility. There's a role to be played by academia. There's a role to be played by the regulators, the governments in general. What I'd like to learn, first from John, and then from Natesh, and then Joerg, yourself, is what are the best ways to reach out to the common man and find out what their concerns are, and how can we educate them on the usability and the benefits of urban air mobility? Please. John, I'd like to start with you.
So first, I don't think I think most people know what it is. Almost everybody knows what Uber is, and you say, okay, Uber, by air. So I don't think that part's hard. I think the real question is educating them or convincing them that they want to have the landing zone in their backyard. Okay, so I think that's going to be the real challenge. In terms of concerns, we've actually done studies. You can do it about, what would people get in a vehicle? Would people get an electric vehicle? Would they get in an autonomous vehicle? One thing we haven't talked much about here is the autonomy piece. One of the other scaling issues is actually crew. So there are not enough pilots in the world to fly the high-scale urban air mobility. So Uber and I think everybody accepts that we're going to in order for this to be feasible at scale, you're going to have to transition to fully autonomous manned operations. So I think that's actually a fundamental challenge that we're going to be facing, which is how do we develop the technology, the automation technologies, at a level that would be allowed to be used operationally. A lot of people talk about certification. Turns out we do know how to certify automation. We certify autopilots and whatever. What we don't really know how to do yet is to allow operational use. So we don't know how to approve a flight without a human on board the flight into the system. So I think that's actually a challenge. So it's a little bit off your topic because it's not a public, but it's the responsibility of the regulatory agencies to maintain the public trust. And the real question is, what will it take for the public to be willing to get onto an automated aircraft the same way they're willing to get onto an automated elevator to go up and down the building?
Thank you. Natesh?
The elevators, fortunately, can only go up and down, and they know how far it'll go. The question was what can we do? In the US in particular, I don't know how it works in the rest of the locations. We are going to have a fundamentally different relationship with the communities with urban air mobility than we have had in the past. So the burden of user acceptance is not going to be strictly on the current regulatory entities, but it'll be on the city mayors and so forth who actually have the responsibility for the landing and takeoff zones and permitting those. So from an impact for the regulatory side, to convince folks, the practices which we have followed in the past might not be sufficient. They won't scale. Our level of engagement with the local communities would have to be dramatically different. Mercifully, we have some experience with deployment of PBN procedures and community's difficulty in accepting them in how to engage. So we'll have to learn from those and take proactive steps. The noise complaint related situation usually implies you have to get ahead of the problem. It is very difficult to fix perceptions after the fact. So we'd have to do more of that early. Part of our challenge is going to be, I don't think the industry knows exactly what the business models are and which ones will be needed. So we'll have to be nimble enough to react. We can't educate the public about something which we don't know exactly what is going to come, what kind of operation. So it'll have to be a very dynamic engagement with the community.
Thank you, Natesh. Joerg, just before you to come in, I wanted to give a quick overview on what's happening with the cities in Europe, at least, a bit more of the European scene. The European Commission has institutionalized a program called the European Innovation Program, which within the smart cities, and there are 42 smart cities in Europe that have signed up to be part of Urban Air Mobility Initiative. And that's the overall umbrella where the city mayors, I'll take a leaf out of what you just said, Natesh, city mayors have come together to identify the needs of their cities, whether it is to solve the problems related to transfer of medical equipment from one end to the other, or the other one is to go from an airport to a city center, and so on and so forth. So that's one way that in Europe this community is being brought together to try and understand what they need and how to satisfy. But I know that Airbus is involved in this initiative, which brings me perhaps, Joerg, to you, and you could highlight how your organization is playing a role, particularly in Toulouse Metropole, I know that you are, but also across Europe.
Thanks, Munish. I would have exactly come to that point as well. I would have explained as well that there's this European initiative, and it's a colleague of mine, Vasily Zagoridas, who's running this on behalf of the European Commission. And this creates these kind of local marketplaces, these local platforms where people and politics and industry can come together and see what it takes locally. Another example that I would like to highlight is that we have used one of these cities, Ingolstadt, north of Munich, a couple of months ago to present for the very first time to the public our City Airbus vehicle. And that's also something that the industry is usually not doing. We usually use air shows, or we have ceremonies, rollout ceremonies, or things like that. But in this case, the very first public presentation was to the general public on a market square in this town, right? And there was a lot of political support on that, and a lot of discussions on all aspects. But it shows as well that it changed the mindset of we are not developing something against people, but we want to develop it with people for the benefit of people, right? And doing this with all the challenges that we're having, and Europe is pretty conservative on that in terms of noise, privacy, all kind of pollution, right? And that's good. That pushes us to get the right answers, but it's very difficult. And all these initiatives that we are taking here are helping to build the right, to take the right choices to make it happen. But the ultimate answer to the question is probably it will take a bit of time, right? It will take time to progress the technologies so that the impact, the negative impacts, noise, pollution, and so on, can be really reduced to minimum, and that shows that it's perfectly safe, yeah? and that it's a benefit for society, and people will embrace it. And the elevator, the bellboys at the beginning probably had also a pretty good position, and probably there were people that didn't like to ride on an elevator without a bellboy. That's just for the last comment on that. It takes a bit of time.
Thank you.
If I may add something, because interestingly, you mentioned that actually we know how to certify automated systems, so it's not really automation that's a difficulty. I think there's one more layer of difficulty as we start having artificial intelligence built in the systems based on machine learning and analyzing lots of data. And so there's one first problem in certifying in the usual sense aircraft, for instance, that involve machine learning based approaches. Some people view these as non-deterministic. I think it's a little misleading in a way. Usually the programs are deterministic, but they're not explicit. Right. So you cannot exactly trace why a decision has been taken. And talking about the general public, I think in general, it's a problem if you cannot explain, if you cannot say what's happening. And then it's a problem for the authorities that will certify, because of course trust is very important. Which brings me to the fact that for this community and for air traffic control, as we start having more integrated and system-wide decisions that are being made, the question of who is going to certify this entire air traffic control system and basically build and guarantee the trust that the public can have in this system. That's yet another layer of difficulty.
Thank you. John, I think you wanted to say something.
Yeah, so I think the AI question is interesting, and there is the AI has to buy its way onto the airplane. And so you have to get enough benefit from the AI that you convince yourself. So the real challenge is that we know how to do inner loops. We don't know necessarily how to do outer loops. But on the other hand, we don't necessarily have to have totally cut the humans out of the system. So for those outer loops, maybe ET calls home and asks for advice as to what to do in this complicated situation. So I think it's interesting to think about that and figure out whether we can certify what I would call non-deterministic, but AI-type systems, or do we basically use those to guide us in designing more deterministic systems that are easier to certify. The other thing on certification in general, we come from a culture of certification on airworthiness. But if you look at ground vehicles, for example, they're not certified. And I think this is actually what happens with air traffic is the agency takes the liability. So technological advance in ground vehicles is limited by liability exposure. So I don't know where we're going to come out on this in a few, but it's an interesting sort of question for the future.
Thank you, John. We're fast approaching about just over 11:20. I've never had a panel that's so well disciplined and so well timely, so it's really good. We've got one more question, and after that we'll open the floor to people. So, Sandy.
Yes, thank you. So we've heard research issues discussed. We've heard the public support, public issues, and many people have touched on, and Natesh actually specifically mentioned business models. So this is another area where things will change somewhat dramatically. So the question, and this will go to Joerg and François. We'll start with you, Joerg. The question is, how are we doing on the business model side? Are there business models? Are we evolving into business models? How do we get from here to there in order to address the issues associated with business models for UAM?
Shall I go first? Okay. Yes, of course. And how these business models will evolve will be very, very interesting and crucial as well, so that we develop the right solutions, services, products to support this business model. So let me just make 2 points. So first of all, the big trend, and I probably don't need to detail it much, the society moves to consuming services instead of buying products. So that's more like we need to sell a service that's compelling to the public. It's a clear trend. The automotive industry will already face it to some extent. And for aerospace, it's obviously a bit easier because people generally buy a flight ticket, and don't buy an airplane for themselves. So, okay, but there's this clear trend of buying mobility solutions, integrated mobility solutions. That's the first thing that changes the business model. Now, what we are doing in our VOOM operations in Sao Paulo and Mexico City, so these helicopter taxi operations, we are a network operator. So we are having a customer that makes a request, and then we are connecting a certified Part 135 operator that then actually owns and operates the helicopters, right? So there's one way of dealing with that. And François can certainly talk more about Uber, who's a very good example for that. Now, how this whole question around infrastructure, for example, will work. Who owns and operates the infrastructure? Will he charge a landing fee as today? And just a little parenthesis, if you land Battersea Heliport in London, you have something like a 300-pound landing fee, right? So that just kills all kind of competitive offering here. So there needs to be a strong evolution in that one as well. And I think there is a lot of room there because a kind of a helipad or vertipad on top of a building gives also some additional value to the building. It channels people through the building, so there can be auxiliary revenues or services or things to be offered. It can improve the attractiveness of the building, of the area. So there's a lot of things that will evolve with that, right, on the infrastructure side. And on the air traffic management side, it was already mentioned, right? This has a huge cost as well to build such an air traffic or such a UTM ATM system and to certify it to these needs. So who will pay for that? Yeah? Somehow the industry, the end passenger that buys a ticket, generate revenues with the network operator, and the network operator will need to remunerate all the investors in the whole value chain so that they can find value in what they are investing in. I would leave it there. Huh?
François, same question too, please.
Okay, well, it's great. I think you've covered most of it. So, of course, from Uber's point of view, definitely we're in this mobility service business, and so we're trying to accommodate the fact that people, as I think you were saying, the new generation of people will not consider owning a car, and so it's really about the service. Providing service. So, as you said, there are a number of types of companies and businesses that will be part of this, building and operating the infrastructures, of course, maybe fleet operators. So I'm making a slight distinction between operating the flights as you're doing, or as we will be doing in New York City with, a Part 135 certified company, but maybe also just operating the fleet in terms of maintenance and making sure that everything runs okay on the hardware side. And then if we look more precisely at the infrastructure, for instance, I know that airports are really dealing also with the passenger experience from end to end, because, for instance, I don't know, luggage, security, organizing all of these passenger experience may create some specific difficulties or opportunities, depending how you look at them. Maybe there will be some specific businesses dealing with very precise and local weather prediction, because this will impact, the efficiency of the service. And so, in the end, I think as of today, it's not entirely clear how the value will be distributed among all these players. It's just clear that we need all of them. And so that's really the approach we have, and that's what I really liked in our Elevate Summit, is that all of these people are coming together and, first of all, trying to make this market and this opportunity exist. And then, of course, there will need to be a fair distribution of value among all of these.
I think, Markus, from Frequentis' point of view, would you like to make a comment on that?
Well, most of the things have been pretty much said, actually. I think there will be a convergence of different types of mobility. I mean, owning the car is definitely something, that's something from the past. I mean, I lived here in Vienna for some time, and if I would still live here, I wouldn't need a car. You go the short distances, you take one of these electric scooters, you pay for them for on a minute or hour price. For a longer ride, you take one of these sharing cars, and you can take that. And for longer distances, for a weekend, you take a rental car, for instance, or take a train. And the same, the urban air mobility part will be integrated in the same system, I would say. It will not have its own pricing system or business model. It will be fairly much integrated into this bigger mobility providers and service providers. So what I think it's going to be a multimodal pricing that is coming here.
Thank you. We've reached to at least the end of our pre-planned part of this discussion. What we'd like to do now is to open the floor for all of you to ask questions. May I request that if you have any questions for NASA, PK, maybe you can ask those questions first, because he has to leave. And then Sandy and I will just walk up to you with our microphone, and then you can ask your question. So the floor is yours.
So I want to go back to the ground a little bit. So Uber announced that its self-driving cars will not be deployed for a long time. Same thing, Google, that predicted that self-driving cars will be in 3 years, now recently pushed it back from 3 years to 30 years. And this is mainly due to technical challenges. So, for example, mainly cybersecurity and attacks. So now it's known, acknowledged that I could design and print a small patch, go and put it, for example, on a stop sign, and the stop sign will be recognized as a speed sign by the AI system that is in the self-driving car. So how do you see the challenges of UAM as compared to the self-driving, let's say, cars? Are they easier, more difficult, or the same? And if we are pushing, self-driving cars to 30 years, at least that's what Google did, how long? So are we 30 years more?
So of course it's always hard to predict, especially the future. But it's not exactly as you mentioned it, because I think the case for self-driving cars, there's been so much hype that 2 years ago everyone was saying we'll have them in 5 years, and I think obviously it was wrong, especially since the implicit promise was that we would have level 5 self-driving cars anywhere. And so in France, for instance, the notoriously difficult Place de l'Étoile, where the Arc de Triomphe is the example that everybody takes, saying, okay, we have to solve for that. At Uber, the approach is slightly different. We think that self-driving cars will be on the roads just in a few years, but in some specific configurations and operations. So in terms of spatial zoning, maybe weather conditions, and so the operational domain has to be very well defined, and then it's possible to use the current technology will let us do this. And the things you mentioned about cybersecurity, yes, there is a sort of an arms race between different AI systems, and can you fool some AI, and then can you detect that somebody is trying to fool you? So that's one technical issue, but I think it can be solved and it can make progress. Now, to your question as to whether it's easier or more difficult in the air, it's very hard. So I'll be cautious here. It's very hard to have a definitive answer. Globally, I would say that in general, it's the same type of techniques that will be used in the decision-making process. So basically having a number of sensors, acquiring information. Maybe one difference in the air is that there will be more reliance on communication, although this is happening also in cars, but communication from vehicle to vehicle and with an infrastructure, with an air traffic control. Maybe the difference is that there will be, and we know, and you know, that there will be an air traffic control system. But based on all this input, communications, sensors, maybe the sensors will be, and certainly they will be slightly different from what you find on cars, because you'll need longer range, maybe you'll need something that can be more focused on areas of interest. But then the decision-making process will be very similar. In one way, I think it may be, and I hope it will be a little bit easier in the air, because of two things. Well, there's less, in a way, there's less clutter than there can be on the ground. We know that on the ground there are many things happening, construction, pedestrians, animals. Of course, there are birds in the air, but maybe they're easier to detect. Maybe, I'm being very prudent here. So that's one thing. And the other aspect is that there will be, and there has to be, an air traffic control system, basically.
Air is technically easier than the car. You're far away from those non-deterministic people.
So there's a whole construct of minimum viable product, and you are seeing the autonomous cars also right now. There are two paths on autonomous cars. So one is fully autonomous in the most complex environment, and other one is changes to evolutionary changes to lane changing and such. There are also another dimension to that, which is the autonomous cars are started already as a minimum viable product operation in the retirement communities where the speeds are slow, environment is a lot more predictable and such. So there are ways to do crawl, walk, run approach where you can get the thing started in an environment where it's a lot less risky, and it's very confined. So the ways to get the product out it proves it's safe, it proves it's beneficial, financially viable, and then slowly evolve to the more complex operations. So that's a path that is likely to occur in this situation also. The things that we didn't talk yet, I'm going to rush through a couple of them, which is in terms of the collaboration with, of course, we want collaboration with regulators, industry, the defense and homeland security type entities to make sure all those aspects are considered, but also local communities who decide where the pads should be placed. There is research that is going on to try to figure out how close we need to put verti pads. So what will happen when there are simultaneous arrivals and departures occurring. So those things need to be thoroughly researched before we actually come up with some standards and requirements. There are also issues related to passenger acceptability in the cabin. You have noise inside cabin, not just outside, but noise inside cabin, vibration issues. All of those need to be sorted out and studied before we have a pretty good idea as to how it will be used and accepted, and how far we can scale this, how close we can keep them and such.
Thank you. Thank you. Any more? One here, one there.
Thank you. Thank you, Sandy. I'd like to explore the security aspects that Natesh mentioned, because I was thinking about this. So, and the question is really for Uber and Airbus. So, I live in Washington, D.C. It's highly restricted airspace. The security people won't let us do much of anything. I assume in Europe, Paris, London, the capitals have similar problems. So are certain markets going to be really off limits for this, or how do you think about that?
Perhaps off limits is a tough word, right? But it will require very different safety or security standards in this case, most probably in terms of whatever passenger screening and means before you let them board an airplane, on how you secure the airplane, how you secure the ground station, the operational centers, and so on. It will probably change very strongly. If I take the experience today in Sao Paulo, you go, we have helipad on the hotel building. You go to the reception. There is a person from the reception coming with you in the elevator and helping you to board the helicopter, and that's it, right? That person has a specific training, and also kind of for firefighting and for security, but it's not a very heavy kind of security measures there. And this is a city where there is the most helicopter operations in the world somehow. So all this will, with scale, change very significantly, and I think here as well, scale will reveal what can happen, what needs to be prevented, what measures need to be taken, and it's difficult to make a kind of a one single answer for the whole world. It will very strongly depend on the different geographies.
Yeah, I think it's clear that there will be different types of markets. As you said, capital cities with governments and strategic places will probably be off limits. I don't know, for Paris, for instance, the city of Paris is completely basically a no-fly zone, except for emergencies, and that will probably remain. Now, the Paris case is interesting because it's actually a fairly dense and compact city, so you could have vertiports all around the city and still manage to provide an interesting service. And then, of course, you have to get there, but that's okay. We want to work on this multimodal experience anyway. But I think that basically there will be maybe a handful of types or categories of cities and markets, depending on the type of, the extent of the city. Is it denser or smaller? Does it have a fairly small number of dense pockets, or is it fairly uniform? Does it have waterways or highways that can be used and maybe that can be leveraged to allow for easier operations? And then the local regulation, because based on the local public acceptance, which will also vary between different markets. So yes, definitely, I think the different markets may be slightly different. Still, I'm thinking that there will be a fairly small number of categories that each market can fall in one of those.
Yeah, I have a thought about this also because we are dealing with a lot of police forces around the world, and what we see here is, I don't have a question for this, but the question is security enforcement. How is that actually happening in the case of urban air mobility? Because if you're driving on the road and you're driving too fast or making something, you have a cop showing up behind you and stopping you. So how will that be with urban air mobility? I don't have an answer to this, sorry, but I think that's going to be an interesting field of research, how police intervention, policing can actually also improve in the case of urban air mobility. And unfortunately, the Gatwick drone incident really has shown that there is something that needs to be done to improve that.
I think, Mike, you're going to be the last question.
Okay,
So
yeah,
make it
and
good.
I think PK will want to weigh in on this, but maybe John and Natesh. So John mentioned that ATM will be very expensive in this environment, and I guess I would expect that you'd have a private ATM service provider, and the venture capitalists would invest in that, and they'd be willing to invest a lot of money. So I guess, is that paradigm correct? Of course, I think the FAA is going to invest to certify it, and so would you comment on that? That my mental model, and sort of how much the FAA would have to invest on their side to do certification, for example.
So I don't think the market will pay for that. So the venture capitalist who wants to invest and thinks they're going to get a bunch of money out of that is probably off base. I think that the real issue will be who has access, who owns access to the high-value airspace. Right now, that's owned either by the governments or the air traffic service providers. I don't see them giving them that up. They're not going to give up that control. So I think it will. I mean, it's an interesting question. I think they may contract out. There may be service providers to do it. I personally think it would only be one per metro area. I can't see. I mean, I can't see how you would have multiple service providers, simultaneously covering that. But I mean, I think one of the real challenges is, does the business model, add up? I mean, sit down there and think about this, right? We just had to pay for the security to get the guy into the passenger into the vehicle. You got to pay for the vehicle. You got to pay for the pilot. You got to pay for air traffic control. You got to pay for the takeoff and landing zone. I think this will be even though it would be nice to say it's going to be massive and for everybody, I think ultimately it's going to be a high-value product for high-value services, whether they're medevac, and I think the societal one are medevac emergency services in whatever, and then there's some other ones that come on, because I don't see these things reducing costs at scale, which is, the fundamental scale argument if you're going to make it cheap.
I might have a slightly different perspective. There's still a lot of people who appreciate the high value. They fly first class. They want to go supersonic. So I think there are members that would like to take advantage of this, and they will be or could be able to afford it. The venture capitalists are already providing sort of resources and funding for airspace solutions. We see at least 10 companies, maybe more, who have been funded by VCs to provide airspace, what we call USS, which is US Service Suppliers. They provide services, and I think the goal here is to accommodate multiple service suppliers who will interoperate and interact through common data standards for exchanging information and such, rather than a singular provider. Now, I agree with John on one point, which is that FAA will still, in US at least, maintain the authority over operations and certification. So they will still have the authority. They can put directives, constraints at their as necessary, but there could be a role for multiple service suppliers to provide services for flight planning, weather, and a whole bunch of others, tracking vehicles, ComNav surveillance and such, but they will have to be interacting to each other through interoperable standards, data standards and such.
Just a short question. Talking about 20 years in advance, if you go 20 years back, there are some people who remember that in the Bay Area there was helicopter access to the airport, and there were at least four heliports. So maybe somebody can tell us why it hasn't survived. Because one was in Marin County, rich area, the other was Northeast Bay, and there were two more. I would also like to remind the older ones that there was another service to Manhattan 40 years ago, and we know what happened. And it was very important part of mobility, because here, through the conversation, you can see the airport access is one of the main sources of business, I would say. So I don't know, maybe as you are from Bay Area, you know why in 80s it was pretty active.
So we studied this. Most of the helicopter, there was a big round of helicopter service providers in the U.S. in the 60s and 70s. Most of those went out of business for financial reasons. There was a safety issue in New York with the Pan Am accident, which actually disallowed helicopter operations in Manhattan. So the reason why you take a helicopter from a pier in Manhattan is the takeoff and landing is not over the land in Manhattan, it's there. Having said that, because they've gone away, it's now very hard to break in with the noise issues. So if you try to reintroduce helicopter services, now you have to deal with the noise issues. So the noise is definitely a problem, but most of them didn't go away from noise, they went away for financial misuse.
Thank you.
And there is I think there's already operations in New York. Blade is doing it in a number of cities. These guys are advertising. I think Airbus is looking to launch some operations. So this is going to be a retry. So we'll see how that works. But.
Excellent. Thank you all for your questions. Thanks for your participation. I hope you found this panel discussion interesting. I certainly did. It's been a pleasure. I'd like to thank my panelists. Thank you very much for your participation. I hope you have a wonderful rest of the afternoon and the day. And for those of you who are here for lunch, well, if you've got another opportunity to ask more questions from our panelists. Thank you all. Have a great day.
Okay, thanks.